Rational functions and graphs. Now, remember when we did our basic functions and we had our function y equals 1 over x. And we called that the reciprocal function, but it is also the basic rational function. And we did not spend a lot of time on it at that point, but now we're going to really focus on it and see how rational functions work. The word rational, the first 5 letters are ratio, which means a comparison of one thing to another, like a fraction. So rational functions are functions that have polynomials with x in the denominator. So this is the first type, this is the first one of those that we've looked at this semester. First thing I'm going to have us do is do a t-table, and we're going to plot some values of x. Now, we're not going to continue to graph this way, but I want you to understand why rational functions work the way they do. So I'm going to give you some x's, and you're going to find the y's. So if we put the 100 in for x, then y is 1 over 100. If I'm going to jump down here to the 1 over 100, remember 1 over 100 is the same thing as 1 times 100 over 1, which is 100. So if I have 1 over 100 and I plug it in for x, y is equal to 100, and so on. So I want you to go ahead and do these values, and I'm not doing them in very good order here, but I want you to go ahead and do that. And think about what those ordered pairs would be. And now you see why it's called the reciprocal function, because if I put in 100, I get 1 over 100. That's its reciprocal. If I put in 1 over 100, my output is 100, which is its reciprocal. So I want you to go ahead and fill in the rest of the table, and then go ahead and plot those points. And I'm going to, obviously this is not really to scale, but just so you can get an idea. Here, don't do that one. Let me erase that. All right. You're not going to be able to do the 1,000 ones on here. Just go out to 100. And this will be 1, and this will be 10, and so on. So go ahead and plot those points. And obviously when you get to 1 over 100 and so on, you're just going to be getting very close to the axis. You're not going to really be able to plot those. So go ahead and pause your video for a minute, find those values, and plot those points. When you're finished, turn the video back on. Okay, so hopefully you've done this yourself, and we found that each of these was its reciprocal, and we plotted each of those. So we have 1, 1, and then when x is 10, y is 1/10, and when x is, it should be 100. When x is 100, y is 1 over 100. I can't really plot that, but I'm just getting closer and closer to the axis. Now when we get closer to the x-axis, we see that when x is 1 over 10, about right here, then y is, oh, for crying out loud, this should be 10. when x is 1 over 10, y is 10. And when x is 1 over 100, which I can't really plot, but it's very, very close to the x-axis, y is 100. So we see, as we're getting further and further out on the x-axis, y is getting closer and closer and closer. And as I come back, towards the axis this way, as I get closer and closer and closer to the x-axis this way, we're getting closer and closer to the axis on that side. So we see how we have that big curve, which we knew from our original memorization is what the graph looked like. Now, if I put negatives in front of all of these, then that's going to make all of these negatives. And it would plot all the points over here, my negative x values and my negative y values, the same way. And so that's what my graph is going to look like. Well, if I could graph, hold on, let me try this again. All right, well, just pretend that's a nice smooth curve there. Okay, so that is what a rational function looks like. Now, let's talk about some specific things on this graph. Notice here, as x is going to infinity, what's happening to y? It's getting closer and closer and closer to the y-axis. Y is going to 0. And as x is going to negative infinity over here, y is coming up to 0 from the other side. It never actually reaches the x-axis. It just gets smaller and smaller. 1 over 1,000, 1 over 1,000,000, 1 over 1,000,000,000, and so on. But it never actually reaches the axis. And it certainly never crosses over to the other side. So this line right here this line that it's getting closer and closer to is called an asymptote. The line that the graph is getting close to and moving along there is the asymptote. In this case, it's a horizontal asymptote because it is a horizontal line. And for this particular one, our horizontal asymptote is the line y equals 0. We also have that behavior where the graph is getting closer and closer over here to this axis and not crossing over. Now that one happens for completely different reasons, and we'll actually talk about that in our next lesson. And that is called a vertical asymptote because it is a vertical line. So the line that it's getting closer to that causes that behavior is the one that is the asymptote. It is not a part of our actual graph. So our vertical asymptote here on this one is the y-axis, which is the line x equals 0. We're going to talk about vertical asymptotes as a lesson, and then the next lesson will be horizontal asymptotes, and then we're going to talk about some special things that can happen on rational functions called holes. That will be our next lesson after that.